Assalamu alaikum. This is Aline and I'm gonna solve problems on learning outcome 8 of static fluids Archimedes principle. Question number 1. Based on the table of densities, decide whether the object would float or sink in the following situations. Situation 1. A block of solid paraffin in molasses. Paraffin at density is less than molasses, so it would be float. So A will float. A bar of gold and mercury. Gold has a higher density than mercury, so it will sink. So B will sink. So this answer will be wrong. Piece of platinum in gasoline. Platinum and gasoline density is larger than gasoline, so it will be sink. So C will sink. So this will be true. D. A block of paraffin in gasoline. Paraffin in gasoline. Paraffin has a larger density, so it will sink. So this answer would be the only A would float, as B and C and D will sink. Question number 2. A cup of water having ice cube floating in it is placed on a pan of balance. What happens when the ice completely melts? The key word here is floating. When object is floats, so its weight will equal the buoyant force. So if the object doesn't change or the weight doesn't change, the buoyant force will be the same. So the weight of the cup unchanged and the level of the water in the cup remains the same, as ice has a smaller density than water and it has a larger volume. So when it will melt, the the larger density of water will have a smaller volume, so the buoyant force will remain the same and the level of water will remain the same. Question number 3. The buoyant force acting on a floating ship. Buoyant force of the object is floating, so it will equal the ship weight. Question number 4. The reason that a ship floats is that it displaces a lot of water. The displaced water wants to return to its original location. So, if a ship carries a heavy cargo, if the ship carries a heavy cargo, there is a change in the buoyant force, and that the change in buoyant force will be accomplished by a change in volume of the object beneath the water surface. So the displaced volume increases and so the FB will increase. So it will dip deeper into the water, which creates a stronger buoyancy directly with weight. Question number 5. A loaded ship passes from a lake or fresh water to an ocean or salt water. The salt water is more dense than fresh water, and the result the ship will the ship will be floated on the water surface, so the weight will equal the buoyant force that equals rho Vg. Salt water has a larger density. Density and volume are inversely proportional. So salt water which has a larger density will have a smaller volume. So the ship will ride higher in the water to displace less volume in the seawater than the fresh water. Question number 6. The Belimissol line as shown in this figures which determine every depth for four different densities of waters as illustrated in this table. Based on Belimissol line, which of the following statements is true? Let's see. The ship can be loaded with a heavier load in fresh water than in sea waters. No, as in fresh water, the ship which has maximum load when it is be in fresh waters, the displaced volume increased, and that's not true. A ship will submerge deeper in seawater than in freshwater, not true, as the volume in seawater will be less as its density will be higher. So let's see this answers. Ship with the same load will float higher in cold regions than in tropics. Cold regions is weight equal buoyant force. Cold regions have a larger density than tropics. Tropics, which are the hot waters. So the displaced volume of cold regions, as its density is larger, the displaced volume will be less. So the ship will float higher to displace less volume. So this is right answer. Question number 7. A piece of iron and a piece of wood stick to each other as in the figure and are floating. Floating that the weight equals the buoyant force if above the water surface. If they are turned upside down to float as in this figures, which of the following statements is true? As I said, floating things means that its weight equal to the buoyant force. So the upthrust force will remain the same as the object doesn't change in weight. Okay? But the volume of iron or the iron will be totally immersed in water, and thus doesn't mean that the upthrust force will change. Question number 8. You plunge a basketball beneath the surface of a swimming pool until half the volume of the basketball is submerged. If the basketball has a radius of 12 centimeters, the buoyancy of the ball will equal to. We calculate from these relations the total volume of ball, which will equal this value. Then substituting in the buoyant force by half the volume of the basketball and obtain the value of the buoyant force from this relation. Rho is the density of water, which is 1000, and G is 9.8. Question number 9. If you put a beach ball volume رقم ده into the water and don't push it down, the weight of the beach ball in air is 1.5 Newton. Measuring the volume of the beach ball that under the water we found is 153 centimeter cube. What is the buoyant force of water on the ball? Buoyant force equal rho Vg. V is the displaced volume of the object under the water surface, which is this value, but we convert this units into meter cube, so we multiplied it by 10 negative 6, so we will obtain this value as 1.49 Newton. We can say that the buoyant force as the object is floated, the buoyant force equals the weight, and we find that the weight equal 1.5 Newton. Question number 10. If the density of ice is 920 kg per meter cube, what is the percentage of the floating part of ice cube over water surface? We know that the specific gravity equals the the density of objects over the density of waters, and this will be determined the ratio of the submerged part beneath the water surface. So the density of ice over the density of water will equal 0.92. So the floating part will equal 100. This value is the submerged part. So the floating part will equal 100 minus 92, that will equal 80%. The same here, ice cube floats in salty water, density and 10% of the cube appears above the water surface. So density of ice over density of water will equal 100 minus 10, that it will equal 90. 90% will be submerged in the water, so the density of ice will equal this value. Number 12. If a uniform body weighs 50 Newton in air and 30 Newton in water, its specific gravity equals weight in air over the weight immersed in water. Weight in air over weight immersed in water, so it will equal weight in air over weight immersed in water, which is the weight in air minus weight in water. So it will equal 50 over 50 minus 30, that it will equal 2.5. Specific gravity don't have units. Number 13. A gold cube is dropped into water to sink to the bottom. Which statement is correct when the cube stays still at the base? Stays still at the base, so it will be sunk as its density will be larger and its weight will be larger than the buoyant force. So the net force or the apparent weight will equal weight minus buoyant force. So the resultant or the net force of the resultant of the pressing force exerted by water on the cup is less than the weight of the cube. This force, resultant force, will be less than the weight, as it will be we subtract the buoyant force, the value of the buoyant force. Question number 14. A body is dropped in 4 different liquids, A, B, C, and D. The position of the body in each liquid is indicated in the diagram below, in which case the buoyant force in the body is the least. Buoyant force equal rho Vg, density of liquid, volume of the part of liquid in the water, and this will be the least volume of liquid in the water, so this will has the least buoyant force. Sorry, this answer B will be the true one, not C. Will be as when comparing the buoyant force for C and D, C will be the least, but B is sunken, so it will has less buoyant force than C. Okay, sorry for this mistake. Question number 15. Lead and iron blocks of equal volume sink in water. Density of lead is larger than the density of iron. As they have the same volume and they are sunken, they will have an equal buoyant force acting on lead and iron blocks. The same buoyant force as the buoyant force equal rho Vg. Rho is the density of liquid and it doesn't change it in the two containers, and V is the volume of block in water, which is the same, and G is the gravity, so the buoyant force is the same. Question number 16. Lead has a greater density than iron, and both metals are denser than water. Is the buoyant force indeed objects is the same here as this, but the key words here, he said that they sank, but here he said that they are denser than water. Denser than water means that the total volume of the object is immersed in water. So the buoyant force is equal for the two objects. Question number 17. Wood and iron blocks have equal volumes. Wood floats while iron sinks in water. As we said before, the buoyant force equals rho Vg, density of liquid, which is the same V, the volume of the immersed part of the object in the water. So, as the wood floats, as its density is lesser than iron, its volume beneath the water surface will be smaller than the iron. So, the buoyant force on wood will be lesser, will be greater. Sorry, it will be greater for iron and lesser in wood. So we choose this. A greater buoyant force acts on iron with its total volume under the water surface. Question number 18. If the buoyant force acting on a submarine at the level at the water surface is x, x is beginning of the value of the buoyant force, which graph correctly represents the change in the buoyant force acting on submarine as it sinks in water to a certain depth. As the submarine sinks in water, its volume beneath the water surface will be increased, that by the buoyant force will be increased, until it will be submerged totally with its volume in the water surface. Its buoyant force will be constant with increasing depth. With increasing depth, the buoyant force is the same as the volume will be constant. Question number 19. A hollowed metal sphere is dropped in water vessel. If the sphere is suspended in the water, which statement is true? As we see here, this is a sphere with its volume is V1, and this is the volume of space. The buoyant force, as it is suspended in the water surface, the buoyant force equal weight. The buoyant force equal density of liquid, gravitational field strength times volume, total volume, that's the metal sphere, and the space displaced from the water. But the real weight here will have only the volume of sphere, that will equal the total volume of the the volume of sphere and volume of space minus the volume of space. So, according to this relation, volume here in the buoyant force will be larger than this volume. So, according to this relations, where the density is inversely proportional to the volume, the density of the sphere here will be greater than the density of water. Will be greater as the volume is less. Okay. The same here. Hollowed metal spheres, but we taken the same problem, but we taken this from Kenya to Sweden, will G is greater. As G is greater, the weight will be increased, and so the buoyant force will be increased. Sorry, here doesn't cancel with each other. He asking for the value of the buoyant force. The value of the buoyant force will be increased according to the first value. Okay? The apparent weight of an object changes in an elevator while accelerating upward. A fruit seller sells his fruit using a beam balance in an elevator while he gains more if the elevator is accelerating up? Will he gain more? He is asking, will he gain more if the elevator is accelerating up? No, because the weight when the object is suspended with the weight, total weight will equal the buoyant force, whereas the buoyant force increased, the buoyant force will be increased, so it will has no increase in weights on both sides, as the weight will be increased or gained much weight equally on both sides. Question number 22. Two identical inflated balloons, one with helium balloon and the other with carbon dioxide. The helium balloon rises while the carbon dioxide balloon falls to the ground. They will have equal buoyant force for both balloons, but they are sorry, they are in the air. The buoyant force equal rho Vg, and the density is the same, which is the density of air, and V is the volume of the two balloons, which are the same, but the balloon with lesser density will be floating and the higher density will be sank. Question number 23. Each of two objects of wood and iron is weighted using a spring balance on Earth. Spring balance reads the same. Suppose you use the spring balance to weight them on the moon. In this case, what would happen for the weights? For on Earth, for the apparent weight of both objects on Earth to be the same, the volume of wood objects must be more than an iron, and buoyant force of wood must be higher, as the buoyant force equal rho Vg, and the volume here is larger, so the buoyant force will be larger. The buoyant force is larger, so it lifts it higher. So once they are moved to the moon, the buoyant force goes away, as there is no atmosphere and of course no density. So the buoyant force will be equal 0. So the wood object will be only on the buoyant force, and the only force acting is the weight. As the buoyant force that was very high is removed, so the weight of wood block would be higher than the iron block. Okay? The object that requires more force to be lifted, when this force is removed, its weight, of course, is larger. Question number 24. Figure above shows a beaker of water. Y is W1. A beaker W2 is suspended in water by spring balance that reads W3, which is a suitable formula that calculates the scale readings. Scale here, which is a balance here, and this balance determines the total weight of this set. So it will be the weight of the container, which is W1, plus the weight of the object immersed in water, which is equal to the real value minus its weight in the water. So it will equal W1 plus W2 minus W3. Question number 25. The spring scales reads differentially when weighting the object in air and when immersed in water. Which statement is correct? As there is a buoyant force here, so the weight in water will be less than the weight in air. The last one, if the figure there is a pong ball, and they have the same weight of a steel ball, what will happen to the scale? Let's illustrate the case here. The first ball here is suspended or attached by string to from up, and the another one is attached by string to the bottom. So when the ball is submerged in water and it is hanged with a thread FT, it's that the tension force, which is the apparent weight, will equal weight minus Fb upon force. When the object is tied to a thread to the bottom of the container, the net force or the apparent weight will equal buoyant force minus weight. So, as they have the same the same volume, and they are immersed in the same water container, so the buoyant force of the two balls will be the same. So the only force here that the buoyant force will be the same. The forces that are acting here will be the weight, so it will tip right, will tip in the larger weight, larger ball, the steel ball. That Beaker 1 will increase by weight of pink ball itself, as the two are equal in the buoyant force. Thank you. See you later.